Hello everyone, welcome back to another video. In today's video, we'll be focusing on how to solve an integration by partial fractions question. So let's first read the question. The question is, the integral of 4 over x squared plus 5x minus 14 times dx. So the first thing to do in this situation is to find the roots of the x squared plus 5x minus 14, which in this case would just be 4 over x plus 7 times x minus 2, right? So now using those roots, we put each of these roots over or under a letter. So it should look like this. A over x plus 7 plus b over x minus 2. So now that we have this, our next step would be to have a common denominator between both the x plus 7 and the x minus 2. So we would multiply the x minus 2 by the a and the x plus 7 by the b. So let's do that. So a times the x minus 2 plus b times the x plus 7. And we put that over the combined x plus 7 times x minus 2. And so that would get us ax minus 2a plus bx plus 7b. And we put that all over our x plus 7 times x minus 2. So after all that is done, we need to set up a system of equations. So that would be in relation to the ax and the bx to the just the negative 2a and the plus 7b. So typically the last value of each section, or the negative 2a, which is the last a, and the 7b, which is the last b, will be in relation to the constant, which in this case would be 4. So let's set that up. So our first part of the system of linear equation would just be the negative 2a plus 7b is equal to 4. And the next part would be the ax plus bx. If you look over here, actually, if you look over here, the ax and bx. So these would not be in relation to the constant, because the constant, as we mentioned earlier, is only in relation to the last value of the a's and the b's and so forth. So let's write that down. So the ax plus bx in this case would equal 0. Wait, so we don't need the x, I forgot about that. We also don't need to have the x's when we make linear system of linear equations, because we simply would not work. So we just leave it as a plus b is equal to 0. And let's look back at our original equation and to understand why we would put 0. So the main reason of why we put 0 is that typically whenever we have these ax plus bx values, there normally is something like an x squared or a 2x plus 4. But in this case, there's no numbers in front of the constant, which means that there's simply 0, nothing. But if it was something like a 2x plus 4, then we would set the ax plus bx, or later on a plus b, to equal 2. But since we don't have that at just a 4 or just a constant, we would only give a value, the 2a plus 7b, which makes the ax plus bx just equal 0 because there's no value it corresponds to. Now, using the system of linear equations, let's try to solve for b. So in order to do this, we'd multiply everything on the bottom by 2. And 2 times 0 is just 0. So, and then if we add them up, that is 9b is equal to 4. We divide by 9. So b is equal to 4 over 9. Right? So let's plug this into the original equation, which will, by original equation, I mean system of linear equations. So the easiest one to find what the a value is would be to use what this system was before, which was just a plus b is equal to 0. So if we plug in 4 over 9 for b, that'd just be a plus 4 over 9, or sorry, yeah, a plus 4 over 9 is equal to 0. So in order to find what a is, we subtract 4 over 9 on both sides, and we would just get a is equal to negative 4 over 9. So we got our b value, and we got our a value. Now using those, we need to bring back this equation right here, which is the 4 over x plus 7 times the x minus 2, like all over, equals the a over x plus 7 plus b over x minus 2. So if we go over there, we got our b value, we got our a value. So we have to remember, we have to put this under an integral. So that'd be the integral of negative 4 over 9 all over the x plus 7 plus the integral of 4 over 9 x plus 2. Right. So what that actually means, so let's set this apart real quick. So from here, all we have to do is take out the negative 4, 9 on each sides and just take the integral of 1 over x plus 7 and 1 over x plus 2, which is just ln of x plus 2 and ln of x plus 7. So let's write that down. So ln, and we have to do and we have to put an absolute value sign. So don't forget that. X plus 7 plus the ln of x plus 2. So you might be wondering, what happens with the 4 over 9? Since this is a constant that has just been multiplied into the equation, we can just put it outside of the ln for both sides. So the first one, since it's x plus 7, it corresponds to negative 4 over 9. We just put negative 4 over 9 ln x plus 7. And the same rule applies for the 4 over 9 in relation to the x plus 2. So we make this 4 over 9 times the ln of x plus 2. And just to check this over, we need to have everything that is in the range of the ln to be an absolute value. And so our final answer would just be this, the negative 4 over 9 times the ln of x plus 7 plus 4 over 9 ln of x plus 2. And since this is a indefinite, or sorry, this is a, yes, this is an indefinite integral, you have to add c at the end. So let's add c, and then we're done. So I hope you enjoyed today's video. Remember to like and subscribe, and I hope to see you in the next video. Thanks.